the inference training efficiency things that DeepSeek has done and the training efficiency things that DeepSeek has done, we don't know that Tesla has not figured out similar things because Tesla is not open sourced.
So first, there are people who are very concerned saying DeepSeek is making me rethink about FSD, full self-driving, Tesla. The Chinese may solve autonomy first. I hate to admit it. I mean, this is just, who knows who's saying this, but there are quite a number of people who automatically think that what they heard from DeepSeek, which is this new large language model that immediately came out and becoming as good as OpenAI's O1, but much, much less needs for chips and cost to do it, that this means that if they can use that technology, they can then apply it to autonomy. Then there are other people, like this person here, who says, actually, it's good for Tesla. Number one, Tesla, all of their compute can work at 5 times efficiency within the next couple of months. Because DeepSeek is open source, people can understand what they did and how they approached it, their breakthroughs for using to become more efficient. That's going to be good for Tesla because now they can use that as well. DeepSeek may have provided the path to make hardware 3 work with FSD. One of the things that DeepSeek's able to do is at the inference level, much more efficient. So more power can be done at the edge computer, in this case, a car, the computer there. Maybe hardware 3s can now be much easier to use FSD. Both facts accelerate Teslas enormously. The modes of data, EV manufacturing profitability, and ability to scale manufacturing at high scale remain. So regardless if that can help, if actually going to help Tesla, but maybe Tesla can't be beaten anyways. And then we're going to go through what Andre Karpathy said. We'll do that just in a short while here. So what's your quick comments on what you're hearing so far?
On the last two, I would say that it is never impossible that someone could come out of the woodwork and beat Tesla at their own game at solving autonomy first. But for them to do that, it would basically require them to solve AGI in the robot, in the car. And to do that, they would have to have quite a bit of data. Now, maybe they can come up, like if you really solve the intelligence piece of AGI in autonomous robots or autonomous vehicles specifically, you can potentially do that with less data, potentially. But we don't have any examples yet of a system like that being developed one shot from ground zero without involving a huge process of data collection that did involve some sort of humans. And so the classic example of this is when DeepMind beat Lee Sedol in Go with their AlphaGo neural network that was at the time the best Go playing computer program in history. They had to train that on lots of human games. And once they figured out how to do that, you have to use what we know through the human experience, and you have to put that into the model as data so that it can learn the first time. Once you have that, then you can close the loop and you can create this completely automated system that doesn't need any more data. And because you can automate it, you can run it 1,000,000 times over and over again. And then you can do what's called just pure reinforcement learning. And you can train from a whole new system from scratch where it will then play the AlphaZero version of AlphaGo significantly outperformed AlphaGo. But it did that because when it was a terrible Go playing program, it could play the AlphaGo program completely autonomously. And then eventually they were able to even go beyond that and have some very fun and interesting, completely automated training processes. But we've never done that where we didn't have a critical step along the process of building something like AlphaZero that didn't involve this human data and human-based data. So that's the challenge that we're going to have, that anyone who wants to beat Tesla is going to have to solve. They're going to have to do something that's never really been done before. And while this DeepSeek paper is very, very, or not just the paper, but the model, it's very impressive. There's a number of really cool things that they've done. They have not discovered any new methods in the core science of machine learning. They have done a lot of engineering that has figured out how to apply ideas that existed in fun, unique, valuable ways. They figured out how to do some things that people have speculated about for a long time, but no one has achieved, or at least no one has achieved in a way that they've shared publicly. And so those are great developments, but they haven't shown us anything that would indicate that they just automatically now have a magic wand that they can pass to some, startup AV company in China that can then just blow past Tesla. It would be an absolute shock to anyone and everyone in the field if someone, took a learning from DeepSeek over to like Baidu or something, and then Baidu was just able to, press the easy button on FSD and solve it. Because, that data that Tesla has is still an extremely, extremely important, valuable asset. And then they also have all the other resources, the compute, the very cutting edge of machine learning research. The thing is, people are assuming that DeepSeek knows things that no one else knows just because DeepSeek open sourced it. There's really 3 important points of progress that DeepSeek just made. One of them was they figured out how to train their neural nets more efficiently using less power. The second one is now they also figured out how to do inference with less power, less time, less compute. Then, more importantly, in my opinion, they figured out how to do training using a lot more automatic computer-based reinforcement learning that doesn't require those humans. But they have the advantage of being able to use some other systems that have already developed a level of maturity based on using humans. So, DeepSeek can bounce their knowledge off of the ChatGPT 01 API, and they can check, hey, how are we doing? Are we succeeding in these tasks? Are we producing replies that are of high quality? And the answer is yes or no, because you can check it against ChatGPT 01 and you can see how it compares. And so I don't know that you could just, develop that without having that standard that you can really measure yourself against well. And I could be, not fully understanding how they've done what they've done and the significance of that, but that's my understanding.
Yeah.
So, yeah.
Okay. So the autonomous companies in China, one is Baidu, right? They have 2,000 cars. Then you got Waymo, Google owned here. They have 1,000 cars. And they're capturing data, but it's still minimal.
Yeah, it's nowhere on the scale of what Tesla's capturing.
Tesla's
and they certainly don't have the
years.
maturity of the system of being able to find what specific piece of data do you need to put into your training set. Because Tesla has the ability to gather 1,000 times more data than they actually put in the training set when they go ahead and tell the Cortex cluster in Texas, okay, take this data, now figure out how to learn the patterns from this data and spit out an artificial intelligence driver on the other end.
Okay.
And,
so I think, right, you've spoken to a number of, we're going to read what Andrej Karpathy said. He's the ex-Tesla vice president of autonomy. He weighed in on this as well. But in general, what you're saying is that in order to solve autonomy, you still need massive data. You still need the massive computer to be able to absorb all that data, which comes in the form of video. And then from there, you might be able to use these breakthroughs that DeepSeek did to actually increase and speed this along. So it is helpful what they did to other autonomous companies. And we'll talk later about the inference breakthrough, needing less inference, which is the computer at let's say the car in this case, or the bot, what they can do. But they still need this.
Yes.
Just to very clarify that's your understanding.
That's my position. And the so the point that I was driving towards on the inference side, the inference training efficiency things that DeepSeek has done, and the training efficiency things that DeepSeek has done, we don't know that Tesla has not figured out similar things, because Tesla is not open sourced. And one of the things was the reason that DeepSeek wanted to solve these training and inference restraint problems was because they had massive constraints on the resources that they had access, not massive, they had constraints on the resources that they had access to. And Tesla has had those same constraints. So they were up against the same types of problems, especially, trying to fit the model of FSD version 12 and 13 onto hardware 3.
Hardware 3.
That is a massive constraint. So you have to be very, very innovative on how you get that inference computer to do what you want it to do. And so they've had the same type of pressure on them that produced the level of breakthroughs at DeepSeek. So I wouldn't be surprised if Tesla has already, if what the rest of the world is coming to learn about how you build these models from DeepSeek are not things that Tesla either already knew or at least already was well on the way to learning. And so I don't know that this is like an overnight unlock. Yeah.
Okay. Let's look at what Andre Karpathy said. So Andre Karpathy was the previous vice president in charge of Tesla's autonomy. And he said this: I don't have too much to add on top of my earlier post on V3. And I think it applies to R1 too.
For the audience, V3 was a paper was some publications that happened by DeepSeek back in December when they were telling the world, hey, we've figured out some interesting things. And then the R1 model is when now everyone gets to play with the release of these learnings and see, how good they are.
Okay, so he says this: I will say that deep learning has a legendary ravenous appetite for compute like no other algorithm that has ever been developed in AI. You may not always be utilizing it fully, but I would never bet against compute as the upper bound for achievable intelligence in the long run. So he's basically saying that you still need as much compute as you can get your hands on, just because
one of the big
this tech
narratives that was out there over the weekend is that, this DeepSeek thing means that we don't need all these chips from NVIDIA anymore, and NVIDIA is going to struggle to sell, chips in 2026 or whenever, because now we can be so much more efficient. And that is just not the way that artificial intelligence has ever worked. Every time we figured out how to make them more efficient, we want more of them. And this is called Jevons paradox. And you can, if you want to go look up Satya Nadella or, Jensen talking about Jevons paradox, it essentially is exactly this: that if all of a sudden, like DeepSeek for ChatGPT o1 type performance just made it 5 times more efficient and way, way cheaper. And because it's way, way cheaper, this is intelligence that you have access to.
It's going to
and so if it's cheaper, you want more of it, and not the same amount at less money. You want more at less money. And so, this is going to expand the economic viability of continuing to learn, research, develop new products. Everything now just got easier for everybody because this is an open source thing. Everyone can now, who hasn't already figured these specific concepts out, now can add these into what they're doing to make what they're doing more effective.
Okay, then he says this: data has historically been seen as a separate category from compute, but even data is downstream of compute to a large extent. You can spend compute to create data. True, tons of it. So that's why you still need as much compute as you can, because you can actually create simulation out of it. Yeah, you've heard this called synthetic data generation, but that's obviously, there's a very deep connection, covariance even, between synthetic data generation and reinforcement learning. In the trial and error learning process in reinforcement learning, the trial is model generating, synthetic, which it then learns from based on the error. Conversely, when you generate synthetic data and then rank or filter it in any way, your filter is straight up equivalent to a 0-1 advantage function. Congrats, you're doing crappy RL. Can you explain this?
He's saying that you can do through simulation. You can try learning, and then if you have some sort of a test to say, did my learning make my system work better or not through that reward, then you can advance and your model can get better. If you have the ability to say the model is better or worse, and then you have the ability to run some simulation or just run your model, then it might cost you more in computation, because you actually have to run the compute for those cycles. But you can add to the model's ability to grow. And yeah, this is moving towards the thing that Alpha Zero was able to figure out, is that once you can 100% automate the process of the neural net learning how to do whatever the task is that you're doing, once you can make it something that runs 100% on the computer automatically, then you use whatever your compute budget is to get as good as possible, as fast as possible. And these tasks that are super hard to do, that are much harder than playing Go, you need a very, very large budget of compute to do those things. And so there are problems that we want to solve that we have not solved yet, that now being able to do this reasoning and thinking faster, cheaper, allows us to solve new problems. And because we can solve those new problems, and those problems are useful and economically viable to solve, then we will use the compute that already exists, and we'll try to get more next year.